Good afternoon, everyone. It's an honor to be here with you today. My name is Samuel Roncal, and I am a systems engineer. I'm 30 years old, and I am a person that has a deep passion for technology and innovation. I have been fortunate to pursue a career that blends my interests with impactful work. I currently work as a software consultant at Universidad Verón Lyon and as a software developer at Pragmatic. So I enjoy programming in Python, PHP, JavaScript, with some frameworks like Angular and things like that. My curiosity always drives me to explore the fascinating world of artificial intelligence. Specifically, I'm passionate about researching applications that combine sentiment analysis, computer vision, and the development of reactive agents. So these fields represent exciting opportunities to create intelligent, adaptive systems that can transform the way we interact with technology. So today I'm thrilled to share with you the topic that is event-driven architecture integration for the development of an artificial intelligence agent to care for mental health. So together we will dive into some key concepts. So thank you for being here and let's get started. So let's talk about event-driven architecture. It's a style of software design in which system components communicate by exchanging events. So an event is a signal or message that indicates that something has happened. A user click, a task was completed, or a change in that data occurred. So we can talk about some key elements that are decoupling, asynchronous, and reactivity. For example, let's talk about decoupling. We have event senders that we can talk as producers that do not need to know who will receive the event, and event receivers that are kindly known as consumers that do not need to know who generated them. So this allows the components to evolve independently. Talking about asynchronous, events are usually processed asynchronously, so which improves system performance and scalability. And if we talk about reactivity, we can talk about systems that react in real time to events. So they dynamically adapt to changes. So we can talk about some components. We have mentioned some of them a little bit before. Event producers that generates events when a relevant action occurs, consumers that receive and process the emitted events, messaging corner or systems. That means that through which events are transmitted. So it can be an event bus, a message kiwi, or a publish subscribe systems like Solus has. Solus event broker, for example, somewhere like that. And we have the events, the data or messages that describes what happened. So they can contain details about the action that triggered the event. We have some advantage if we take this design software pattern for our solutions. We have scalability, we have flexibility, we have some real-time reaction, and more things like that. We have some challenges, for example, the complexity, the ordering of events, the debugging, but we have some really good software like Solus Event Broker. We can put a mesh event broker mesh so we can handle these challenges. So we can use this pattern if we need to generate some reaction that is the consequence for an action that makes that our user makes. For example, if he wants to fulfill a socket form, we can schedule an email sending task just after the user makes the click. So we have a publisher that tells our broker with a message that the user has finished the form. We have a consumer that is listening the message, and we can do some actions with that with agnostic language mechanism. So we can talk about an agent. An artificial intelligence agent is a software entity that is designed to perceive its environment, reason, and make decisions to achieve a specific goal. So these agents operate autonomously or semi-autonomously, and in many cases, they can learn and improve their performance over the time. So that's a really good feature of them. And we can mention some of the basic components of an AI agent, like perception, like decision making, actuation, and in some cases, learning. Because some agents are able to learn from the experience of using their behavior to improve in the future. For example, an AI agent playing video games learns strategies to win over time. We have some recommendation systems that we can see on many of our streaming services. So things like that.
Yep.
So we have some types of AI agents. We have some rule-based, some reactive agents, some agents with a limited memory, some agents that have a specific goal, and some agents that has the capability to learn. So how we can combine an event-driven architecture pattern and these functionalities of an AI agent and benefits and challenges, and we can make a solution for a problem that exists in our reality. So I can talk about the use case. In this case, I have designed AI agent for suicide prevention. So it works with this in this way. An AI agent that acts as a psychiatric assistant can use the event-driven pattern and WebSockets to provide real-time monitoring and alerts for at-risk individuals. For example, I am a psychiatric and I am start talking with my patient. So my patient tells me, "Oh, I had a really bad day. I didn't eat. I am not answering calls because I feel so depressed." So me as a psychiatric, I will start to take notes about that so I can make a diagnosis. So the idea of this AI agent is to create a chatbot that works as a psychiatric assistant, so it can take all the relevant information by an input, in this case, text input. So we can use some sentimental analysis, and we can decrypt, and we can detect, and we can prevent a suicide for a person, for our patient. So it will work with some approximations because that's the kind of work that we have. No? And we have some core components for this system. For example, we have the event producers that we will be the data sources, the user input. It can grow even more because actually it will use user inputs for this demonstration, but it can grow with social media inputs by biometric data, but interaction patterns, for example, hair rate, sleep patterns. We can analyze some posts on social media. So we can have so many inputs that make the AI agent work more precisely. For on another side, we have the sentiment analysis engine, and we have to start talking about natural language processing. For what? We needed to identifying negative emotions like sadness, despair, hopelessness, suicidal phrases like "I can't take this anymore," "I wish I wasn't there," "I wish I could be different," and some things like that. We have some behavioral analysis to detect these patterns at risk over the time, because that's the greatest future that it will have. So we can make a scoring system internally. We can decrypt with a risk score when our patient is in a suicidal risk. So we will need event notification, because when the risk score is reached, an event is triggered. So that's the most important part of the system. This is the most important thing, because we need to react. If we have some solution that is always make a request, it won't be comfortable, it won't be with some benefits. So it will be a little bit hard to take the investments. The price is going to be a really big high. So we cannot make some lack performance systems. So we have this pattern for help us. We have the real-time alerts that are WebSockets. So we can use push notifications or use something like a toast on an alert or things like that. It will be really important to allow bidirectional communication, because if we received the notification, so we will have to make some decisions over the data. So finally, it can improve with some dashboards and things like that. And that's something interesting. So we will have to know the most common reasons for suicide. For example, mental health disorders, social isolations, traumas, chronic pain, illness, financial or occupational stress, breath loss, and things that are really very known, and we can take over literature for getting more specifically diagnosis. So we take all these common reasons, we take the event-driven pattern, we take the sentiment analysis detection. Example, we will need to identify suicidal language, understand the context, track the emotional trends, and analyze the metadata. And we will use GPT-4o for this, with some specific context for the prompt. In future, we can implement also a RAG dictionary, so it will be more precise, specifically with all the historical data of our patient. So that will be really great. If we can take in the scenario or as a workflow, we have this. So my user types, my patient don't see the point of living anymore. He doesn't see that. So the workflow will be an event trigger, because the sentiment analysis engine detects the high risk message. So it makes start the process. An event is created, okay, with a risk score, with a user ID, with a timestamp and text content. So our consumer gets the message, sends the WebSocket notification, and the psychiatrist can follow up in the case. So that will be the workflow. We have some advantages for combining these technologies in that way, because we have real-time monitoring, because it detects and notifies risk immediately, minimizing delays in intervention. We have scalability, because event-driven systems can handle large volumes of user interactions efficiently. We have some asynchronous processing, because it will take a risk score, so sentiment analysis and risk evaluation happen independently of user input, because it's asynchronous, and also it's agnostic. And we have some dynamic alerts and bidirectional communication, because WebSocket gives us that feature, because it allows instant follow-up by our psychiatrist, so we can create a feedback loop. So now we are going to see the demo. Okay, so we can make some conclusions at the end, and let's start with that. So now we can test our example. So I have an Angular application that is made with Node.js also, and I have a simple form that is going to be the mechanism for register all our messages that we can collect with the interview with our patient, because now we are doing or acting like a mental health doctor or a psychiatrist or a psychologist. So I have the simple form, and also I have on the right side an history form. So let's connect. Okay. Okay, so it says that it's successfully connected and ready to publish the messages. So I can start my consumer. So I'm going to use the default syntax for starting our consumer using Node.js and the default uh, domain, port, and credentials that Solus broker use. Now I am subscribed to the topic, so I am ready to receive the messages. So I have some statements here for making our test. So let's imagine that our patient feels hopeless. He's a little tired, but shows a desire to change. So I can use the send button, and our consumer is going to receive it. And the answer from our agent that is using ChatGPT and GPT-4o model, it returned a false. And it also explains the reason of that. Where the patient may experience feeling of hopelessness and tiredness, the fact that they also express a desire to change suggests that they have some level of motivation and hope for the future. This indicates that they might not be an immediate risk for suicide, depression, or anxiety. However, it is still important to continue monitoring their mental health and providing support. So the last part is the most important. It's still important to continue monitoring. So now let's go and register a new statement. Let's imagine is our next session. And it says, my patient has changed his mind. He has trouble eating. And let's see. The statement now from the answer of our GPT agent is true because he started feeling hopeless, a little tired. He used to show a desire to change, but now he's not eating. So the change in the appetite, such as trouble eating, can be a symptom of depression or anxiety, it tells our agent. Additionally, changing one's mind frequently could indicate internal turmoil or indecisiveness. So that's the most important thing because we made the simulation that a person has changed its opinion. So it's not constant. And that's a thing that we have to analyze. It is important to further assess the patient's mental health and risk of self-harm or suicide in this case as well. So now, let's register a next statement. Okay, so it has that. My patient has problems at home. Apparently, she also has financial problems. And the statement also is true on the last, because the patient is facing multiple stressors, including problems at home and financial difficulties, which can contribute to feelings of depression or anxiety. These stressors may also impact the patient's overall sense of well-being and increase the risk of mental health issues such as depression or anxiety. It is important to further assess the patient's mental health and provide appropriate support and resources. So now we can see that we can use this flag, that is Boolean, so we can send a notification to our mobile application, maybe another web application or things like that. And the nice part on this is that we can track all the events by Solus broker. So let's see which of our consumer is tracking that. Okay, so now let's go and make a new statement register. So now let's say that my patient has stopped eating and is not answering calls. Okay. So we can see the answer from our agent. It is still being true. And now we can see that the messages changed because our consumer is tracking the messages, and also it is going to be in the receive sections because we can trigger the next steps in our consumer application. And that's it. That's all the example that shows how to use these really nice technologies and make some good solution for that. Okay, in conclusion, this system, by combining event-driven architecture, sentiment analysis, and WebSockets, can act as an early warning system for suicide prevention. It empowers psychiatrists to intervene in real time, potentially saving lives while offering users a sense of connection and care. So in this way, we can elaborate solutions that impact society with the highest level of technology in an efficient way. So thank you for listening and blessings. Thanks.